Hello, everyone, and welcome to the Virtual Jug again, once again, and this is going to be another fun session. Today we have Catherine Stanley. Catherine or Kate?
Kate, I think. Catherine's my official name. But
okay, right. Catherine's maybe what your parents call you, is it?
Yeah.
Yeah, my wife's the same. Everyone calls my wife Liz, but her mum and dad calls her very much Elizabeth. So it's just like. So, Kate, welcome to the Virtual Jug. This is actually your first Virtual Jug session, right?
Yes, it is. I'm very excited.
So a big warm welcome to the Virtual Jug, and you'll have to let me know afterwards how it goes, because a lot of people say it's kind of tough because you can't actually see the audience, so you can't actually see whether you're going too fast, too slow, or whatever. So give me some feedback about how it goes. And Catherine, today you're going to be talking about microservices communication.
Yes, I am indeed. Hopefully I'll be able to give a good introduction, and then people can go away and start building microservices that communicate better.
Awesome. And right now, looking at the background, you look to be in Hursley, is that right?
I am indeed in Hursley, yeah. Out the window, it's currently light.
I still recognise the blinds at IBM. How cool is that? So Kate, what do you do at IBM?
So currently I'm in the IBM Cloud team. I'm working on Java specifically. So we've been doing a lot around generating Java applications to run on the cloud, both for Spring and Java EE microprofile, that kind of thing. So that's been my main focus at the moment, but sort of combining that with microservices. So in the past, I've been focused more on microservices, but now we're doing a little bit of both. So you can now go and generate all sorts of different applications to run on the IBM Cloud that run Java very nicely.
Awesome, that sounds very good. And actually, there's been some really interesting information. We mentioned it actually on our podcast just this last week about IBM open sourcing some amazing stuff. We have OpenJ9 now, and we have OpenLiberty.io, right?
Yeah, we do. So that's really exciting. And it's obviously, I've known about it a bit longer, but it's only just been announced. So that's really exciting as well. And actually, I'm heading to Java 1 next week. So people see this and then want to come and say hi, they can. But there's going to be a lot of people talking about that at Java 1 as well, I think.
Awesome, I'll see you there.
Very exciting stuff.
Yeah, it is. So for those people who don't know what that is, what's obviously J9 is the IBM's JDK, and that's not built on top of OpenJDK, but it uses parts of OpenJDK, right? And so that's now been open sourced. And what's Liberty for those who haven't heard of it?
So WebSphere Liberty is our application server. So people might have heard of WebSphere Liberty or Webster in the past being a sort of more scary application server that was very, very powerful, but not very developer friendly. And Liberty is the more sort of composable, cloud native friendly, developer friendly version of that. It's really lovely to use. I worked in it for quite a few years before my current job, and it's so nice to develop on, but it's just as powerful as traditional application server. So it's fully sort of production ready and provides anything you might want from a Java application server, including as well supporting microprofile, of course. And then, yeah, they've open sourced the sort of base part of it, which is really exciting.
And that's kind of like at microprofile kind of level, right? So it's it's that core part that's been open sourced, and that's an Eclipse project now. So Liberty.io for more information on that. So before we start, and before I hand over to Catherine, actually a little bit of information for the Virtual Jug viewers. If you'd like to ask any questions of Kate as we go through, IRC is, if you're watching via the virtualjug.com page, IRC is just to the right-hand side. Actually, if you're looking, it's probably this side. The right-hand side of the page. You can have discussion in there and ask Kate any questions. If those questions by the time they've been typed are still relevant to what Kate's talking about, I'll interrupt on the most relevant ones to get some discussion and get some good interaction. Otherwise, I may leave it to the end. But do feel free to ask your questions in IRC. Also, at the bottom right, is that here maybe, or here? I can remember. I know in my left and right, I just don't know how it's put up on the screen. But on the bottom right, there's a little settings cog. Make sure you click on that and get your highest resolution so that you'll get the best viewing experience. And that's for obviously if you're watching on replay or live as well. The Virtual Jug sponsored by Zero Turnaround, so do check out some of their products as well on zeroturnaround.com. And yeah, without further ado, Kate, I shall pass over to you.
Cool. So if I share my presentation, where is it gone? There we go. Okay, hopefully you can see the first slide.
That's right, yep.
So as we said, I'm going to be talking about microservice communication and integration. What are my options? So we already did a brief introduction. So most of this we kind of covered. If you want to tweet me, then feel free. It's at KateStanley91. And the other thing I want to mention here, because it will become relevant later, is I've also worked on the text-based adventure game called GameOn, which is a microservice text game written mostly in Java, but some other languages as well. Hopefully some of you have tried it out, and I'll be demoing it if you come and see me at the IBM booth at Java 1 next week, but I'll talk a little bit more about that later. So the contents for this presentation. I'm going to do a little introduction to what are microservices, just in case there's some people who haven't actually seen them before. Then why communication is really important. What are your sort of options when it comes to communication? And with that, what data types you might want to consider, the infrastructure options you might want, and some characteristics to think about as well. Then finally, I'll talk about producing and consuming APIs, followed by a conclusion at the end. So firstly, what are microservices? They're used to compose a complex application using small, independent, autonomous, replaceable processes that communicate via language agnostic APIs. There's a lot of buzz around microservices at the moment, so hopefully some of you do know a little bit about what they are, but this is sort of it in a nutshell. And there are some key attributes that I want to pull out before we head into communication, because these will become relevant a little bit later on. So the first one is that they're scoped to a specific function. So within your microservice system, each application has a single thing that it does, and that it does really well. The second thing is that they're independently deployable, and then sort of linked to that, they're then independently scaled. So each individual microservice that does its one thing really well can be individually deployed and iterated, new versions can be put up, and then it can be scaled independently as well. There are a whole bunch of resources for you to go read more about microservices. I've put a few down at the bottom here. The first one is Martin Fowler's website, which is really just got a whole host of different things and is a good place to start. If you like a good book, you can read Sam Newman's Building Microservices, for example. And then I've got two on the end here that have been around a little bit longer, but are still very relevant, just domain-driven design, which will help you kind of think about how to services and what parts you might need, and then release it for the sort of design and deployment parts.
And just to add to that, actually, the Building Microservices book by Sam Newman, I'm pretty sure Roberto Cortez did a book reading club with the VJug, so we actually have some previous videos with Sam talking through that book. So I'll post that into VJug IRC as well. Nice segue.
Cool. Yeah, so before I go on to communication, the last thing I want to say is there's a lot of people talking about microservices, and it's a really big buzzword, but that doesn't mean that it's the answer to all of your problems, unfortunately. So whenever I give a talk on microservices, I always say, don't assume it will fix everything. Go and read about it, and it may well be perfect for your scenario, but there are some disadvantages that come with it, or some things that you might have to think a bit more about. So just don't assume it's going to be an easy ride all the way. So with that sort of caveat in place, let's assume you know all about microservices, and we'll go on to communication. So why is communication important? So I'm first going to talk a little bit about my team and how we communicate. So as I said at the beginning, as Simon said, I work for IBM, and it's a worldwide organization, which means that my colleagues are in different locations. They're also in different time zones, up to sort of 6 or 7 hours maybe in a different time zone, and also potentially different languages, which is an interesting one, because actually all of my colleagues do speak English, but we don't, due to this quote here: the United States and Great Britain are two countries separated by a common language. And this is a quote that has been attributed to various different people, but I've definitely found it to be true when chatting to some of my US colleagues. There are, first off, different words that we use for the same thing, or the same words that mean slightly different things in the two different countries. And that's just the start of it. And we've definitely found that having different locations and time zones, and then this sort of half language barrier, has meant that we've had to think very carefully about how we communicate and how we can communicate effectively. And the reason why I've introduced it like this is because I think this kind of does apply to microservices as well. Microservice communication concerns that you might have. It's a distributed system, so the microservices are in different locations and might not know where the other services in the system are. There are different release cycles, so the different microservices might be updated at different times, and that kind of links back to the time zone thing, where people could be pushing things out, and you can't necessarily always have everything being released at once. You might have to have staggered releasing. And then also different languages. And here, when I say languages, I don't just mean different programming languages. You might have a polyglot microservice with Python and Swift and Java and JavaScript and Node, or all the different languages and frameworks you might want. But also, even within one particular language and one particular framework, people in different teams might implement things differently. So there might be some differences in conventions there that could trip you up. So how did we solve it in my team? Well, when I was looking back at the kind of journey we've come on and how we've got to a place where we communicate reasonably effectively, I felt there were three sort of key things that we sorted out. The first thing was what sort of data type we would use. So here I mean, like, do we talk by text? Is it actual out loud speaking? Is it body language? And then what tools are we going to use? So email, Slack, Skype, and then what characteristics we can get within those different tools. So if you send someone an email, they might reply that same day, but you've got to kind of assume that they might spend a week before they reply. Whereas if you phone someone up on Skype and say, can I ask you a question, you expect them to respond and not just ignore you to your face. So these are the three kind of sections that I felt it sort of broke down into. And we use a combination of all the different data types and different infrastructure that I've written down here in order to communicate effectively in different scenarios. So again, going back to microservices, I think this then splits out into these three sections. So first, you need to choose your data type, and this should be language agnostic. One of the things I said right at the beginning was microservices communicate via language agnostic APIs. The second one is infrastructure. You need to think about if you want a service registry or a service proxy, perhaps. And these are things I'm going to go into later in the presentation. And then finally, your different characteristics. And here, talking about asynchronous versus synchronous. So that's similar to the sort of delayed or immediate response you might have with maybe email versus Skype or something. So first off, data. As I said, it should be language agnostic. And this is kind of the first thing you want to get agreed, because if you're all sending different data types, then it's going to become a bit of a tangle to work out which services can talk to which ones. So if you all agree on one, then you will make your life a lot easier. The big ones that I've seen people using is XML, although potentially a little bit outdated now. JSON, of course, which is very popular. And then there are binary protocols like Thrift. But I think it's best to start with JSON because it's sort of well known, well used. And also, if you're looking at a microservice that's either polyglot straight away or might become polyglot as time goes on, then having something like JSON is useful because languages such as JavaScript rely very heavily on JSON. And actually, when you're looking at several different languages, you'll find that JSON is often one that can be agreed upon by everyone. So then on to infrastructure options. So the first thing you'll want to think about when you're looking at microservice communication is how do I find my microservices? So if we think back to my original introduction to microservices, I said that they're all deployed and scaled independently. And that means there's no known endpoint for your microservice, which means that you need a service registry. You need to find a way to locate your services without having to have a known endpoint. It might be that to begin with, it's tempting to set up known endpoints, but as soon as you have any real load or want to update with a new version of a microservice, you're going to find quite quickly that having known endpoints is a problem. So a service registry is simply a store of available microservices. It provides a few different things. Firstly, registration and deregistration. So a mechanism for the microservice to announce that it's up and running and at a particular location. And then, of course, if it does need to be shut down for some reason, deregistering itself. Now, you'll often hear alongside microservices discussion about 12-factor applications. I'm not going to go into 12-factor applications here, but one of the things that's talked about a lot with 12-factor applications is being able to have an application that can start up quickly, but also be shut down without having to do any pre-shutdown sort of clear up. It might be that for some reason your microservice just gets blown away. And if it has to do deregistration before it shuts down, then you might end up with a registry that's full of loads of services that aren't there anymore. So that's where the health check comes in. So you should have, with your service registry, a mechanism either for the microservice to send a heartbeat. That's probably the most common way to do it. And then if it doesn't send a heartbeat after a certain amount of time, the service registry would just strike it off the list. Or perhaps you could have the service registry poll the microservice, but that might not be the best scenario. And then the other option is actually if you've got your applications hosted on a cloud platform, for example, that understands the applications themselves, it might be that the platform can provide the health check information and tell the service registry if it believes the service has gone down. The final piece that the service registry needs to provide is service discovery. So as well as having a list of what services are up and running, it needs to have a way for microservices to go and find one of the services in that list and then find out where it's located. When you're looking at service registries, there's a key thing to consider is consistency versus availability. And here you do have a choice that you need to make, and the different implementations lean towards consistency versus availability. And the reason for this is related to the CAP theorem. So you can only have one of consistency, availability, and partition tolerance. And which one you choose really does depend on the application. So for example, if you're running a system like Netflix, for example, where you need to provide lots of video data and you don't want to be concerned about people, that you always want someone to be able to view the data, you want them to be able to get to a video, but you don't really mind about them consistently being able to see the same video or be able to see the same information about the video or the same point in time on that video, then you might lean towards availability. And some examples of ones you can use is Eureka or Console. Eureka actually is more availability, and then Console provides consistency. Also, if you're using Kubernetes, you could use a platform like Istio as well to provide you with some service registries. So you definitely don't need to write one yourself, and you'll see a theme throughout this presentation that a lot of these tools are already available. It's just about understanding your application and your system of microservices so that you can make that choice. So next I'm going to talk about routing requests. And the two types I'll talk about is using a service proxy and then some client-side routing as well. But before I go into that, I just wanted to talk about caching and load balancing. Whenever you're doing routing in a microservice, you should think about caching and where you can cache information rather than going and getting it again. One of the things that I think often people forget about microservices is you are in a distributed system. It really is a problem. So if you can reduce the number of requests that you need to make by caching information, then you should definitely do so. And with load
Hey, Catherine, you still there?
Oh, I thought someone said something.
Ah, there we go. Sorry, I lost your audio
Routing
for a
via a
second.
service proxy looks a bit like this. Oh, there we go. Hello?
Hi, can you hear me?
Yeah, I can hear you.
Ah, we're good. Oh, we lost your audio just for a second, but we're good now, I think.
Oh, okay, cool. Maybe it's the Wi-Fi. I don't know. Can you hear me okay now?
Yeah, no, sounds good now. I think it might have just been a hiccup on Hangouts, personally.
Cool. So routing via a service proxy. The way this works is you have your service proxy, which talks to the service registry and gets information about where all the microservices are and where they're located. And this information should be then cached by the service proxy. And then when a microservice wants to make a request, instead of calling to a specific known endpoint of the actual microservice it's calling, it calls into the service proxy, which then proxies the request onto the actual location for the microservice. The advantage of using this over some of the things I'm going to talk about in a minute is the requests are very simple. Your microservice knows that it's calling a service proxy, it just calls it, and then the request gets forwarded on. And it's reasonably simple to test because you don't have to take any calls to the service discovery or service registry. You can just set up a mock version of your service proxy and then have that in your integration testing. So if there's any problems with routing, it's normally fairly easy to debug. The disadvantage of this over the other options are there's quite a few network hops going on. So you're making a request from the microservice to the service proxy, which is a distributed request. The service proxy is running somewhere else, which then makes the call to that microservice, which then responds to the proxy, and then the proxy then passes the request on. And here is where you'll see the latency. And it may not be that you'll see it initially, but once your system becomes under load, then you will start to see a slowdown in how fast it takes for these responses to come back. So the other option is to do client-side routing. Here, it's less network hops. The microservices themselves already have the information from the service registry in a cache locally that says where the different microservices they might want to call are located, and they just make the direct call across the microservice. This can be done in two different ways, either with a client-side library or with a sidecar model. So with the client library, it's language specific, it's built into your application, and you just utilize the library as part of your application. These are language specific, so it does mean if you've got a polyglot microservice, you might have to look for a client library that works with your service registry for all the different languages that you want to support in your microservice. But it provides reasonably easy debugging. Because you've written the code to use the client library yourself, you can debug into that quite happily. And there's a fair few different client libraries that are available for you to use as well, that are already out there and well tested. The other option is to use a sidecar model. With a sidecar, this is normally used for when you're running in containers. So you'd have one container and then two processes running inside the container. So one would be the application and then the other would be your sidecar. The advantage of this is actually, whereas in the client library case, you had to change your microservice to use the client library and then also think about how do I write that in such a way that I can re-implement my microservice without changing the client library code. With the sidecar, your application's a completely separate process. So you can completely re-implement your application and not touch the sidecar at all. It's also language agnostic, so the application could be any language in there, and you can use the same sidecar model across your entire microservice system, and you don't have to worry about finding a different client library for your service registry. The difficulty with this is it is harder to debug failures. If your application looks like it's functioning well, but something's going wrong with the routing, it probably means there's something wrong in the sidecar, and that can be much more difficult to debug. But it's still a very popular model, and Systems such as Istio, that's built on top of Kubernetes, use the sidecar approach. And it, as I said, it is nice to provide you a good way to do everything in a language agnostic way, and really to keep that separation between your application and the sidecar logic that's routing requests. So the final thing I wanted to talk about around the infrastructure kind of area was API gateways. So here, an API gateway provides a coarse-grained API for your microservice. So I said at the beginning that microservices are scoped to specific functions, and they do one thing and do that one thing very well. The result of this is that they're very fine-grained. And actually, if you designed your individual microservices in your system so that they are the perfect API for all of your consumers, you probably haven't scoped your microservice in the right way. And you'll probably find that the actual APIs you want to expose to your clients and your users are much more coarse-grained. And that's where the API gateway comes in. It acts as sort of one entry point for all of your users, and it can then sort of split that API out into different requests to the microservices under the covers. The other useful thing that you get from this is it provides a sort of layer of separation between your users and your implementation. So for microservices, a lot of the draw for people is that they can iterate and reinvent and push forwards their applications much faster than they could before. But if all of your customers are really relying on exactly how your microservices are implemented, then that prevents you from doing that reinvention. So by having an API gateway, it means that there's a layer of separation, and you can re-implement all of the microservices inside your microservices system without having to actually show any of it to the user at all. The other things you can use the API gateway for once you've implemented it is sort of metering APIs. You can use it to expose different APIs depending on whether the user is logged in or not. You can use it as a good location to inject JWTs or JOTs, client-specific APIs. So if you have a microservice system that's supporting sort of a web front end and a mobile front end, you might want to provide different APIs for those two systems depending on what the use case is in each case. And it means you don't have to have loads of different versions of your microservices under the covers. You can just use the API gateway to synchronous versus asynchronous protocols. This is an interesting subject for microservices. If you've gone to many talks about microservices or spoken to many people around messaging, this might be an area that's come up a lot. And I think there's a lot of discussion back and forth, but I'm going to give you my point of view, and then you can go away and kind of think it over and go and see what other people are saying as well. And here I'm talking about specifically synchronous versus asynchronous protocols, as opposed to sort of asynchronous and synchronous programming models. So for synchronous here, we've got REST, HTTP, and then asynchronous is more messaging. And the way I've separated these are: synchronous requires a response. When you send a REST request, you expect some sort of response, even if it's not a response with the actual payload that you're eventually going to get. And then for asynchronous, there's no response required. It's worth noting, though, synchronous requests don't necessarily mean blocking requests. So you can utilize asynchronous programming models so that you're not blocking requests while you're doing synchronous. So my opinion is that you can use both of these in microservices very effectively, and where you use each depends on your microservice in question and what user experience you're going for, and how the different protocols sort of relate to that user experience. But I think the best way to talk about synchronous versus asynchronous is to show you an example. So this is where I'm going to bring in GameOn again. So I mentioned GameOn briefly earlier. It's a text-based adventure game. It's built as microservices. You can see on the right there that it's your classic text base where you type something in, and it's made up of a set of lots of different rooms, and you can move from room to room. And every single room in GameOn is a different microservice that is written by a different person at a different conference or in their spare time or whenever, and then hosted on some different cloud platform. And if you want to come and write your own room, then do come see me at Java 1. You can come and write a room with me. The reason we created GameOn was because we wanted to help people to start writing microservices quickly and easily. And as part of that, we wanted them to be able to see their room once they'd created it. So we created the interactive map. This is the map here. This is just a small section of the rooms that we have. You can see right in the center there's something called first room. It's actually first room, but it's just been cut off a bit. That's the first room that you enter, and it's part of GameOn itself. Everything else on that square, so all the other yellow and orange and blue dots, those are all rooms that have been stood up by somebody else. And the interactive map, this application here, is outside of the core microservices of GameOn. It has been written by my team who do GameOn, but it's not part of the core infrastructure. It runs completely separately. And as I said, the main aim is just to display the name and location of a particular room. So when people create it, they can see it. The scenario that I'm going to talk about to sort of show where you might use synchronous and asynchronous. One, updating their room and then seeing that reflected in the interactive map. So when you're updating, say, the name of your room, you can do it in the panel that we can see here on the left. And update, we then want it to appear in the map. But actually, for a user, when I update the name of my room, I want to know pretty quickly whether it worked. And actually, I want a response that tells me all good. If it fails, then maybe I want to try again. Be that I want to do some sort of validation. So for GameOn itself, for the room name, it doesn't actually have to be unique. But if this was an ID that I was changing, then it might be that I need to validate it in some way, make sure it's unique. Or for a name, I might need to validate that it's got characters that are disallowed, for example. So the updating of the name, as a user, I want a response there, and a pretty immediate response too, so that I can take some other action and choose a different name, for example, if it fails. But for the map, I don't need an immediate update. If it takes a few minutes or a couple of seconds for the update to come through and then I get to see the change, that's not really important to me because I knew what the name was before, and people can still see that there's a room there. It'll just have an out-of-date name. So the first part of this scenario, I want a quick response, and then the second part, kind of as long as it's eventually the right name, I don't mind. So the way we've implemented this in GameOn is like this. So we have an authenticated user at the top who then makes a REST request into an API that we have documented to update their room, and they're doing that through the user interface that I just showed. And that then does an update in something we have called the map service, which then talks to an external data store. And that's a REST request because I want that immediate response. And then to update the interactive map, the map service actually publishes an event that says, this room's been updated and this is the new name of the room. And the interactive map subscribes to that event, and then when it gets the event, it updates its own version of the map and shows that in the UI. And in this case, actually using a synchronous and REST-based protocol here gives me a good user experience because it means that I get the response immediately. The latency isn't that high in that the user is quite happy to sit there and wait for it to say that it's done it successfully. And it means that as a user, I can immediately take some other action if it does fail. Whereas if I did an event for the first part, then it would mean that I would then have to work out what to do if sometime later the event came back saying that something went wrong. but then the user might have gone off and done something else, and we have no way to sort of work out what the next step should be. Should we leave the name the same? Should we try again later? In our case, the best user experience is for REST. And then if you look at the interactive map, we could use REST here. The map service could tell the interactive map, here you go, I've got a new update for you. But actually the map service doesn't need to care whether the interactive map gets the update. It just fires it and forgets it. So that's where the kind of difference between asynchronous and synchronous can come in and can be used very effectively, I believe, in microservices. So for messaging in GameOn itself, we're using Apache Kafka when we're running locally, and then Message Hub when we're running in the cloud. We actually spent quite a bit of time with GameOn working hard to get it to run easily, like as a developer locally, and then run as similarly as possible in the cloud. If you want to sort of learn more about that, feel free to go through the links that I'll put up right at the end to GameOn and read more. But for messaging specifically, if we run Kafka locally, it's easy to set up locally, and then Message Hub in the cloud actually works quite well. So this is an example. It wouldn't be a Java presentation without some Java code, so here's some Java code. We've got it producing a record here, so there's a topic, and the topic here is what the interactive map is subscribing to. So the topic might be sort of map events, for example. And then the key is actually optional, but for example, for room events, we include the ID of the room that's involved, and then the message. And then we can just send that.
Got a quick question, actually, Kate, in from IRC. How do you make putting the stuff data to an external data store and publishing it to a broker atomic?
Yeah, that's an interesting problem. So the way that we've done it here is once we successfully put the data, that's when we send the event, which could mean, the reason that we've done it that way is actually because GameOn, the interactive map, isn't sort of a service that we need to be running all the time or need to be completely up to date. We actually don't mind if it gets slightly out of date. So we've kind of managed to avoid the problem a bit, if that makes sense.
Okay, so they're not done as one single unit of work then?
No, it's done as a sequence of work, because in this case, we weighed up what are the pros and cons, and like, do we mind if the interactive map is slightly out of date?
Playing devil's advocate, how would you do it if you wanted it to be atomic?
I'm not sure.
I mean, I guess
I haven't looked into that in detail. You
could enlist it, I guess, under a JPA transaction if you wanted to do something. JTA transaction, I guess, if you wanted to do that. But then it gets a little bit hairy, I suppose.
Yeah, so I think I think using a mixture of synchronous and asynchronous can work in certain scenarios. The reason I think that people do end up going for messaging across the board is because there's a lot of tools out there that you can use, like with Kafka and things like that, it might be easier to do things as events and then do it across the board, because you would just have one event, if that makes sense.
Sounds good.
So yeah, so that's where I think you have to weigh up whether you want to go messaging across the board or whether there are certain scenarios where you can do something as a simple synchronous request, and the outcomes of doing that don't impact you in ways that you don't want it to. Cool. So moving on to microservice design. So when you're designing your microservices, they should definitely be influenced by the different communications that you want. So we talked a minute ago from the question about whether you'd want everything to be message-based or everything, or a mixture of synchronous versus asynchronous. And actually, if you think about this up front, it means you'll find it easier in the future and you won't have to refactor your application as often. I'll show an example again with GameOn of where we've seen this. The other thing to consider when you're designing your microservice is latency. So when you're doing distributed systems, it's very easy to forget about latency. And I think it's probably one of the things that I talk about the most when I talk about communication, in terms of something to just keep thinking about in the back of your mind. Because making one request, you might not see much latency, but if there's several chained requests, and particularly if there's several chained synchronous requests, that's when you start getting into trouble. And I think, again, that's where often if people are saying that they want to go completely event-based, that does kind of mean that you then won't fall into the trap of doing chained synchronous requests, because I definitely think chained synchronous requests in a microservice are a bad idea. So considering latency as you go along is definitely very important. So when we were creating GameOn itself, this was the first pass that we did of GameOn. You'll notice the map service that I spoke about isn't actually in this first pass. That's because the concierge does eventually sort of become map, but I'll explain more in a sec. So this was the first kind of initial architecture diagram we had. And if you're interested in the whole sort of evolution of GameOn from start to where it is now, then you can go check out our GitHub pages and stuff. But we started off with the idea of a hotel. So we thought, you know, hotel has rooms, players or people go and stay in the rooms, and then you have a concierge that shows you to your room. And that we thought made sense to everyone. We all had this good idea that we all had the same outline of what it should look like. And we had the proxy at the top there, and then we had a player service which dealt with the players and then talked to the database, and then a long-running WebSocket that went across to the room. So the players in the room can send instructions to the room, and they can type sort of messages and things in the room that then other players in the room would see, and we're doing that through a long-running WebSocket. And actually, we found that two things happened. The first was that we discovered the disadvantages of not thinking about domain-driven design, and we potentially didn't design our domains in the best way. What I mean by that is that we discovered quite quickly that the people in the UK had a very different idea of what the concierge was supposed to do and what particular functions it was supposed to perform versus the people in the US. So actually, we hadn't designed our microservices to do one thing and to do one thing very well. And then the other thing that we realized was actually there's two different scaling concerns here. So a long-running WebSocket scales very differently to something that's handling REST requests, which means that not only do we not have well-defined functions, but we also don't have applications that can be scaled independently. So we then moved to more this sort of scenario. And again, we do still have concierge here, but that did eventually become map due to the problem that I discussed of where no one really understood clearly what the concierge was supposed to do. And so in the end, concierge became map, and then map handles the map and the locations of the rooms, and it became a lot clearer. But the service that we added here was mediator. And the mediator mediates between the room and the player, and that's what handles the long-running WebSocket connection. And this means that then you can scale mediator separately to scaling player, and it then meant that actually it was better defined what the different things were doing. So the player service is just in charge of handling player interactions in terms of the data about the player. So what's their name, what's their favorite color, because in GameOn you have to have a favorite color, and then also, you know, what is your login credentials, etc. And then the mediator is what's mediating between the rooms. And if we to have thought about communication from the beginning, as soon as we drew this model, we would have gone, oh, wait a sec, that can't be right. We need to think a bit more about how this is going to work, because if we want to do scaling and we look at the different communication that's happening here, this doesn't quite make sense. So if we'd have thought of communication at the beginning, we probably would have got to what we have now a lot quicker. So the final thing I want to talk about is producing and consuming APIs. The first thing to remember with APIs is that they do change. And actually, in some ways, I think you want them to change because you want to be able to improve your APIs, expand them, and have people use them and, you know, want more from your APIs as time goes on. And there are two kinds of changes that you might need to make. There are changes that are definitely breaking changes, where you might alter what endpoints you have or what data is being produced from those APIs. And then there's the non-breaking changes that theoretically shouldn't break anyone, like adding a new endpoint or adding some data that you're going to consume or produce. And while you're making either of these types of changes, or producing, consuming your own APIs, you should think about the Postle's law, or the robustness principle, which is be conservative in what you send and be liberal in what you accept. Now, this was originally written about TCP implementations, I believe, but it applies to creating APIs. And I'll expand on where I think this applies now. So the first thing I want to talk about is being a good consumer. So when you're consuming APIs, the first thing to note is, along with the robustness principle, you should accept the unknown. So this comes under being liberal in what you accept. So when you get a response from a particular API, you'll probably take in that JSON, and if you're a Java application, convert it to a Java object. And perhaps the default thing to do might be to say, well, if I get something in my JSON object that I don't expect or that's unknown, then I might throw an exception. And certainly in the past, when we've been using perhaps more structured, like, well, not more structured, but XML, things like that, that might have been the default. But actually, you should accept unknown objects in your JSON. And tools such as Jackson, which is a library for converting from a JSON object to a Java object, provide annotations to help you do this. So you can see one here that we use in GameOn. It's got @JSON ignore properties, ignore unknown equals true, which basically means if you get something that's unknown, just don't worry about it. And the reason for accepting unknown attributes is that means that the APIs that you're consuming, the people writing them can add things without breaking you. So it means that your microservice won't fall over if they add something. The second thing is to only validate against the required. So if you're making a request for room information and you require the name and the description, but you don't require, I don't know, say how many doors the room has, don't write the code to validate that you get the name and the description and the number of doors, because it might be that the people producing that API actually decide they don't want to tell anyone the number of doors because no one should really be using it, and then they might get rid of it, and then obviously that would break you. So if you don't actually need the number of doors, don't validate against it. I've put fault tolerance in here because I can't really talk about calling APIs without mentioning fault tolerance. It's a whole other talk in of itself. If you want to learn more, there is some stuff about fault tolerance in an IBM Red Book that I co-wrote, which I'll link at the end. But if you search for fault tolerance microservices, there is plenty of different talks and resources out there. But the one thing I want to pull out is, whenever you're making requests to different APIs, you should always think about fault tolerance and what happens if the request fails or something. And not just when you're calling other services, because actually, if you're using something like Cloudant to store data, that's another service running somewhere that might go down or might not respond or might be slow to respond. Tolerance if you're just making a request to Cloudant, because it's still a request over a network that could fail. So fault tolerance is definitely something to bear in mind no matter who you're calling. So being a good producer. Golden rule, don't break your consumers. They won't thank you for it. And you'll definitely be a much more popular producer of APIs if you don't break your consumers. But it may be that there comes a time where you have to change something. for whatever reason, maybe the way you originally implemented it just doesn't work anymore and you want to do something different and you can't do it in a non-breaking way. And if that is the case, use versioning. And actually use versioning straight away anyway. If you version your APIs right from the beginning, then adding a new version later isn't a big deal. Whereas if you start off with no versioning, then when you suddenly try to add a version, it then becomes more tricky. It just sets a good precedence to say this is the version, and then if you want to move the version forward, people can then adopt it as and when they're ready. You should also, when you're a producer of an API, accept any unknown attributes in the request. You may want to do some validation, you know, to make sure that the request doesn't have anything malicious in it. But if the person calling your API has added an extra object that you don't need, there's no need to throw an exception or to reject the request. You can just say, well, you've given me some extra information, I'm just not going to use it. And equally, you should only return attributes that are relevant to the request. So, for example, if someone asks you for the name of a room, don't give them the name and the description and the number of doors. Just give them the name. Because if you return the name and the description and the number of doors, and then later decide you don't want to tell people how many doors the rooms have, you're then going to break your consumers by removing that information. Whereas if you never intended them to use it and you didn't think it was relevant to the request that's being made, so the final thing around APIs is documenting them. You can follow the robustness principle all you like, but actually if you don't agree on what the APIs should be, then the producer and the consumer will never really get on. And this is definitely something that I've seen sort of difficulty with during my work in terms of having different teams that are producing different microservices and having to all agree on what the API is supposed to look like and exactly what should be, like, you know, what form should that JSON take, what object should be in a particular request, what should their name be, etc. So consumer-driven contract testing is something you should definitely look at. It's kind of what you see is what you get. The consumer writes the contract tests, and then the producer of the API fulfills those tests. And the reason they do it this way around is because it's the consumer really that the API is being written for. Normally, people producing APIs aren't just doing it for the fun of it. They want people to consume them. So actually, if you have it defined by the consumer, then it really will fulfill what it is required. And by having it as specific tests that run as part of your normal test framework, it means you can catch violations of the contract much earlier. Another tool that's really useful is the Open API spec, or Swagger, which is sort of built into it. And this is really good for documenting APIs and providing a way for people to access APIs and try things out, perhaps before they've even written their implementation of the microservice. And this is a tool I've particularly found very useful when we've been working between teams, where a team can put out a new API, perhaps a new version, and say, here you go, here's the Swagger documentation, and then we can go and try it out for ourselves and get a really good understanding for how it works, and then go and implement our side to call that API. And actually, WebSphere Liberty provides I think it's called API Discovery is the feature, but it's a feature that will provide some Swagger support built in, so it provides all of the sort of libraries you need for Swagger, but it also provides this user interface. So if you add it to your server config, then you can have all of your documented Swagger endpoints show up in the way you can see on the screen here. So this particular one is from GameOn itself, and it's using the Liberty API Discovery feature. So in conclusion, you should choose your service discovery and invocation methods. Again, considering what's specific to your microservice application, what are the specific requirements that you need, and remembering that for the most part, you won't have to implement it yourself. You just need to find the right solution for you, because there are plenty of different options out there for you to use. So don't go writing your own service discovery, because there are loads out there that are excellent. Consider both asynchronous and synchronous protocols. I think it is worth considering both, and not just throwing synchronous out immediately and saying everything has to be asynchronous. There are scenarios where you might want to use synchronous as well. Then design should be influenced by communication, thinking about that right at the beginning, and not just leaving it as something later on. Don't stand up your microservices assuming that they know where everything is. Really think about communication from the beginning. And then finally, the robustness principle, and bearing that in mind while you're creating APIs. So that's it from me. I put a bunch of links here. If you want to play GameOn, you can go to GameOn Text. You can build different rooms. I've got a link, where'sdev.net, there is where Liberty information is if you want to learn more about that, and then my red book, and some contact details if you want to tweet me or message me or anything.
Awesome. And Catherine, first of all, thank you very much for that. That was an awesome session. Feel free to post those links straight into the meetup event as well, okay. And then people can actually just click on those links as well. We have a couple of questions in. In fact, there's been some really interesting discussion from Buland and Kubasguba, which is an awesome handle. So we have a question quite early on, actually. It's pretty general, so I thought I'd leave it a little bit. Let me find it. Here we go. So this is from Buland in IRC. I see some concerns around using service proxy and think API GW is a much better option. Can you shed some light of real world examples of using service proxy? So any case studies or anything like that?
So in our case, we were actually using client side. We're using sidecar model for GameOn rather than service proxy. So I think my personal experience has been that using a sidecar model is a lot more flexible, and although it may be more difficult to debug, that's kind of what we've gone towards. I don't know off the top of my head any examples of people using a proxy as opposed to like client libraries and sidecars. I know a lot the client libraries like Ribbon and then Hystrix for fault tolerance and things are very, very popular, and I think that is what people tend to go for more.
Okay, we have a question from Zcube regarding communication with versioning of the API. How can that be achieved in a smoother way when n number of API consumers are present?
Oh, so in terms of having different, I'm not sure.
I think it's if you were to maybe, let's say you're upgrading the application, you have multiple versions at the same time, I presume.
Okay, so in terms of different versions of the APIs, you can use your API gateway to, if you had the version there, you could then have that route to different versions depending on what's in the request, for example. So if there's the particular sort of extra elements that have been added, or it has the particular form that's for that specific version, you could route it that way. In terms of having different versions and like standing up lots of versions and not having too many different versions, I think it's important to try not to update your versions unless you really need to. And of course, once you've updated, to make it easier for people to move across by perhaps having several versions running and saying, well, if you send 2 different types of requests, then I'll route both of them. So it means people can try out the new version while still running the old version for like the majority of their customers or something. Mm-hmm. There's a lot of different tools you can use in terms of like platform-based tools for A/B testing, where you can put up different versions of your microservice and route some traffic to one of them, but the majority to others and things like that. So I think utilizing things like that makes versioning easier and makes it easier for people to upgrade to new versions.
Okay, awesome. We've just hit time, and I know we've both got to go. So I'll just finish by saying a massive thank you to Kate for a great session. Your first session, hopefully one of many. And if anyone is at Java 1, Kate will be there. So do check her out in the IBM stand, and I'll be there as well. So come say hi. And VJUG 24, we now have a full schedule for VJUG 24 happening on October 25th. Our final speaker, we've got Bruce Eckel, which many of you will know from the title Thinking in Java, the famous book. So we have him as our final keynote speaker. So do check that out, and see you next time. In fact, the next time will be VJUG 24, so I'll get my sleep in now. So finally, thank you very much, Kate, and see you all next time.
Thank you. See ya.